Hello everybody. I don't even know what the heck day it is. It's February mid-something. No timestamp. I'm interested enough in talking about what's on my mind that I just jump into the video without my where am I in space-time check. Well, where I am in space is, maybe about halfway through my drive to pick up my kids. So I'll try and keep this on the short side, because as soon as I'm in that neighborhood, I gotta hop, or else I miss exits and stuff. Still very safe. It's easy to multitask while talking like this, except if you've got to remember to exit such and such. There's not a lot of interrupts provided. You're filling up all excess capacity on like switching between things or whatever, that you could miss an exit you plan. So as long as you have an easy task of driving straight, humans multitask very well at non-overlapping categories of activity. So this is a wonderful time to vlog, and I already pushed out a video today, and I even pushed out a video yesterday. I did 2 live broadcasts on YouTube, because I can, of coding sessions, because people do gaming sessions, product unboxings. It's ridiculous, the things that people will put out on YouTube, and it has an audience. It explodes. It's because people relate. And so it seems to me that having this unlimited, live streaming and uploading ability that YouTube has given me, because I've crossed some magic numbers, I might as well use it, right? I like sounding boards, and my favorite sounding board is myself. Hate to sound narcissistic, but once you verbalize something out loud, you can suddenly become your own best critic. And I say best critic because you got to be forgiving with yourself as well. The stuff I do, I know is triggering to some people. It's like, how dare them just be able to think about a topic and talk. There's so many things that are beyond our abilities to control. And an expectation of perfection, of a certain polish, that drives most YouTube video to be extremely edited and, made for the impatient, made for today's audience who, wouldn't just sit and listen. And, who knows? I don't know who, listens to my videos end to end, but who cares if I'm doing it mostly for myself, right? I should not take it personal. It's part of the emotional resiliency, the rolling with the punches that comes with, putting yourself out there. So there's a lot of thin skin, a lot of people who, it's not only thin skin taking stuff personally, I guess it's related to the other thing in that some people just get so triggered by life's events and the, standard goings on, that to keep oneself going in a continuous take video would seem nigh impossible. Well, it's all just in the decision of how much of yourself you want to put out there. If you're okay with putting yourself out there crying, if you end up crying in the course of shooting a video, so be it. Doesn't this seem right? Isn't that the way things are this day and age? Leave polished up editing to future AIs, machine learning systems. They're going to be able to edit together the best excerpts of your messages better than any editor, certainly cheaper and, more variations. And you could query up. Tell me every time Mike did one of these drive talks, summarize the topic, give me some statistics about it. Oh, and edit it together into a best of reel. And that kind of stuff's on the horizon. It's certainly going to happen with everything going into these Google data systems, especially if it's going in with a kind of user agreements and licenses that allow Google to own it and to data mine it and to perhaps even rebroadcast specialized programs. Can you imagine YouTube, 30 years from now, considering how far technology in the web has come in 30 years? Ever since we've been willing to put aside the standard PC model, right? There is a dark ages, a winter. They talk about the AI winter. Well, I talk about the bar of soap on a string mouse winter. Unfortunately, it was copied from one of the alternative techs I love, the Lisp machine. So, in a bizarro parallel, history to today's C programming language and Unix at the heart of everything, right? It's even at the heart of Linux, because Linux had to be written with something. I think it was written on a 386. It might have been with Windows. I don't know. Only Linus Torvalds knows the answers. It might be documented somewhere. But everything in modern tech, modern information tech, is kind of grandchildren of the Unix/C combination, which allowed software to be portable between different hardware, because Unix would be written for different hardware. And then Linux copied Unix, black boxed it, said, oh, let me implement it again, blindfolded, there's terms for it. But there's a lot of stuff in tech which is a, blind implementation of a known behavior. There's nothing illegal about that. This is your implementation. Now, you might copyright protocols and stuff, trying to copyright a language, so even the use of the language is intellectually protected, but that's stupid. So we're undergoing a sort of evolution right now, a human evolution, because what is our DNA but information, right? So the information grows and morphs and changes, right? You are more than just your original strand of DNA. And what we pass on to the next generation is strangely influenced by all kinds of things. Another Michael Levin out there, I think he goes even by the same last name pronunciation as me, but he's a bioengineer? I'm not sure exactly what the terminology is for it, but biological systems, he is able to make generational traits to these flatworms where two-headedness is passed down through reproductive cycles without the DNA having actually been changed. So life is a lot stranger than we think. The influence of our lives on who we are, our essential vibe, if you will, is enormous. We can go against, we can override, or we can live in harmony or enhance or make variations of our original vibe. So the whole who you are thing is it's a part of our existence here. Okay, so before I get too profound, the stuff I really want to talk about, the reason I'm shooting this video is to think through concurrency in Python, how to do all kinds of things concurrent site crawlers, concurrent APIs at the maximum rates they allow with intelligent control so that you don't run over quota limits. Whether it gets chunked, whether you yourself have to deliberately throttle concurrent activities in chunks of 100 from the outside, or whether the already existing APIs for these things accommodate for it and you just give it a number and it will automatically do that internally. And then your objects can grow really tremendously large. If you're like filling a table in memory with concurrent, web page requests, that can explode out of hand. So again, an argument for external chunking, because if you control the chunking of concurrent tasks from outside the task itself, you can cut it off, catch up, and then start another similar concurrent task. And it seems just a lot more controllable to me with bubbles of, multiple threads. So each balloon can hold, 20 simultaneous tasks. You might send a list of maybe 10,000 to one of these, and it's going to process through them, by the 20s, using the resources, allocating it out until it's gone through a list of 1,000. And then you dole it out in 1,000 list-sized chunks so that you can do whatever. Commit to hard drive in a way so that you're neither memory bound or what's the other kind of bound? You want to avoid being memory bound, because otherwise you just drive space, I/O, hard long-term memory storage bound. You can only write as much data as you have storage for. So there's concurrent write issues. Can you write to things concurrently? And a lot of these things that claim to have concurrent write capability, honestly, you can't have phantom write heads writing simultaneously to the media. There's multiplexing going on. At some point, finite resources are divvied out over some switching between otherwise frozen tasks. The frozen task comes alive, it does a little work, it freezes that state, it goes to another frozen task to unfreezes it. So at some point, there is always not real concurrency, right? There's not infinite read-write resources on every connection to everything between every piece of hardware. So magic numbers seem to still play a role in knowledge of what your read-write media is, what your computing resources are. It seems to me that there's still going to be a skill set for knowing how to slice and dice a task, certainly for making the best, most optimized use of your read-write media, your CPU, but also there's a certain artistry that comes into play on the data transforms. There's always stuff being fetched, and there's always stuff being stored. And that fetching and storing so frequently is being fetched over the HTTP protocol with some, perhaps login authentication, maybe some data that has to be carried in the headers as separate from the main requests. So requests are broken into chunks. One of those chunks is like header information, which is invisible, just like web pages have headers, stuff that doesn't display on the page. Communication between systems has headers. So reading and behaving, doing things based on headers is a valuable capability. You might not have to do the whole page load. You might not have to handle and move around as much data as it seems if you do a quick check of header data. That's a thing. But more, relevant to what I want to talk. This videos are going to be over by the time I get up to what I want to talk about. I'm getting down concurrent requests. I'm getting down the chunking when I need to. I can fill a pretty big fire hose with data and put it somewhere. And more often, that somewhere is SQLite, a local instance of SQLite. I did a project recently where I handled about 20 gigabytes, 25 gigabytes of data, and it was all HTTP requests, so there's a whole bunch of URL requests associated with all these gigs of data. And you are paging through it, paging and paging and paging. So if someone has a lot of data they want to give you, they're going to give you something like a URL with a variable component on that URL. Very typically, it's query strings. So according to the HTTP specification, these portions of the URL mean different things. And once you start a question mark after a URL, it's no longer part of the base URL. The uniform resource locator is only up to the part before a question mark, if a question mark is present. After the question mark is data that is intended to vary query string parameters, usually in name-value pair arrangement. Some word equals some value, and then puts ampersands between it. So the very HTTP system itself has a key value pair, mini database. Like a URL can have, here's what you use as lookups for something, right embedded on the URL, because name value pairs can be handled by the thing making the request or serving the request however it likes. It can parse those things and use it how it likes in preparing the data that's going to be returned. So, URLs are database keys. The U of the uniqueness of URLs means that they're legit primary keys. They have a unique constraint. Now, query string parameters do make a twist because the same URL can return potentially infinite variations of the data based on what's on the query string. So there's almost some philosophical debate there, but the HTTP specification is the law. It lays down the law. So, query strings are not part of the URL. They're intended to change. So there's variable input supported as part of the HTTP protocol. Variable input that tends to favor key value pair data, but not necessarily. There's no reason you couldn't put a numeric array hanging off a URL, and that numeric array is as large as that URL is long. That stuff is valid. You can read and parse and do with the data in a URL whatever you like. It's just conventions that make it have the meaning that we've become used to. So you gotta simplify the discussion by saying, when you use a URL as a primary key in a database fashion with a system such as SQLite, you don't want query strings. Chop it off after the question mark. The question mark and after gotta disappear. There will be exceptions. There's always edge cases. But for the most part, when you're making requests of APIs, now I take that back because I think about it. Executing query strings against Google, right? You want to search on such and such a keyword. You got to remember the query string. So the URL is everything that's there, except after the hash mark. The conversation goes on and on because hash marks and Ajax and stuff. But so everything up to a hash mark, including everything after a question mark, it's all valid parts of a primary key when you're using a URL as a primary key for SQL Server. Or not SQL Server, that's I'm thinking Microsoft terms, SQLite. So SQLite, it comes with Python. You can, import SQLite 3 and start using it with raw SQL query strings. I believe the context manager is supported. So if you really get good at raw SQL query strings, you could just casually do SQL stuff using the SQLite dialect, using its very permissive, it's almost like duck data typing. You don't have to define very much about a SQLite database for it to work. So there's certain data integrity issues. What on other database systems or relational database systems or RDBMSs would be, called, data integrity problems is features of SQL Server. I don't think I'd go as far as to say that primary keys don't have to be unique. That's too much. It takes pandas to support a nonsensical concept like that. Pandas, they call it indexes, right? Indexes, multi-column indexes. That's the same thing as primary keys and unique constraints, and multi-column primary keys and unique constraints, and using these things as foreign keys to other tables. Really, there's a lot of potential complexity here. But SQLite always errs on the side of reducing complexity, making it easy for the user to use. So there's a certain amount of dynamicness in there. And we take advantage of that, and we could import SQLite 3 and use the context manager and raw SQL strings. And you would learn something, and you would be better off for it. Create tables the old-fashioned way and all that. However, there is the fact that dictionaries are just the natural interface to data in so many cases that why not just use a NoSQL or a key value pair or a Berkeley DB or DBM, I think is the Unix too. These key value pair databases have been around forever. They're a standard part of Unix and Linux. There's versions of it in there. And, maybe 10 years ago, a bunch of companies liked to pretend like they invented this new a way to do data storage, and we'll call it NoSQL because there's no SQL involved. Well, it's just key value pairs, hash tables, and this has been around forever. It's at the heart of so many different technologies. And any RDBMS system, relational database management system, typically ones where tables have rows and columns, they are two-dimensional matrices of data that very much resemble Excel spreadsheets, which very much resemble pandas, data frames, R frames. And so in computing, there's a lot of rows and column systems with Different indexing methods to access the data, different APIs to interact with matrix-like data. And by definition, if you make two columns, one which is your unique constraint primary key, and another which is your data of, very liberal potential data types, everything from blobs, binary large objects, to text files, not text files, but places where you can store text, a text field of nearly unlimited size, or it could be primitive data types. It could be integers, it could be another Python dictionary, it could be a list. So key value pairs where the key is, usually a string, sometimes an integer, but is the main thing as the unique constraint. There are supposed to be no additional numerical indexes in there in addition to the, truth is everyone loves their numerical indexes, so there's, indexed arrays or indexed dictionaries and stuff, ordered dicts. There's all kinds of variations that you can import in Python if you want some strange synthesis of APIs for your objects. And I usually do away with all of that. I like, named tuples. Okay, so from collections, I'll often import named tuples, which is one of my favorite custom data objects. I know there's also, I think they're called data classes. Some people like these slightly more complex ways to define data objects that have pedantic attention to, the permissible values inside of it. Objects that are a bit self-aware about what they are allowed to contain. They got some specifications. So I believe those are Python data classes, if I remember correctly. There's a much simpler version called named tuples that give you all kinds of lovely little API usability advantages. I showed it in an earlier live video I shot today on YouTube. If you switch over to the live video tab on my channel, you can check me out using them. So, where am I? All RDBMS systems can be turned into a key value pair database. You just use the two-column table. Some databases are made to just be in that two-column mode. Redis is a popular one. Memcached. There's a few out there that are really locked into that key value or NoSQL approach. If you're talking the NoSQL options, there's CouchDB, there's MongoDB, there's a bunch, and they all have different pluses and minuses. They're acidic versus basic, uncompromising of quality, acidic. Or, there might take some time before all the data catches up, if it even does, and that's basic. How permissive these things are, because they're often used over distributed systems where chunks or shards of the data are all different places. So you need to know how pedantic and anal retentive you want to be about, guaranteeing results within times and of certain size, job sizes. But again, complexity. I keep looking for the simplified answers to these things. You push the complexity around to be at exactly the right point. So the complexity at the right point is to just bite the bullet and pip install SQLite dict. I wish it was FSpec or some other heavily used library by some other heavily used package, so that, I could be assured of long-term support, it'd be around forever. But what SQLite dict does could be re-implemented by someone else pretty easily. It covers the critical piece in the Python ecosystem of turning SQLite, which is already there. SQLite is already with Python, it's already with so many systems, but to turn it into a key value database. So you can use the Python dictionary or dict API. See? Key value pairs for storing lots of data to the hard drive, for fast writes and commits to the drive, for fast later on lookups, scanning through the whole thing, stepping through it record by record, either by lookup from some external list that controls it, or internally step through each record in the database. You want to step through things potentially in either way. You might check against some original thing that made your primary key. So there's going to be some loop that makes your primary keys. It's going to define the API calls. So a bunch of URLs typically. But that's not a pure way to store your data. You want to store your data as tuples or named tuples. You want to store the arguments. So you loop through dates, you loop through, say, websites. So for each website, for each date, do some lookup. So your primary key, you want the name of the website without necessarily the whole HTTP : it's very redundant. Just the name of the website, the registered domain, the one that would, plus subdomain if used, right? So www.google.com or such. That becomes a perfect key to some lookup, something that you're going to store, say the HTML of that page. Oh no, not the HTML. We're talking about answers to API calls. So a website and a date range. Tell me some statistic about Google on such and such a date. So your primary key is going to be made from the website and the date website, unique constraint, compound primary key. Tuple or named tuple. That becomes a key in a key value pair. But you can't use objects in memory as a primary key. You got to convert it into a string. Enter pickle. Pickle load, and S is for whether it's a string or not, so we would use the S in this case. So pickle.loads and pickle.saves, I think. That always confuses me. I wish they had better language. Maybe it's load and save. It would be nice to have S stand for like plural. It's very confusing. But you can pickle a tuple, pickle named tuple, and that makes a perfect primary key. Now to treat it as a tuple again later, after say you're stepping through your keys, you're stepping through, the pickled version of a key. So it's going to be readable text. But when you unpickle it, it's going to be that object in memory again, and you have the, thing that you can use the data for some other purpose if you wanted to. Here's the website, and here is the date for which that were used in the API call. Maybe I'll even put the name of the function in there when I create these things, so you know what parameters to feed to what function to produce this data again. That is the key to the database. Can you not see the beauty in such a workflow approach? And that's applicable everywhere. That's an everywhere on almost all projects sort of thing, for a raw data capture phase of the project. And then it transforms after that. You're going to have to step through that data for each record in the database. Again, we're using the context manager and SQLite dict, and sort of reversing the process of the data capture. So you set a object in memory, usually data equals db square brackets, you plug something in there. And if you're doing for key in database, for key in database, then what you plug in there is key. So on your iteration, you actually are sitting on the primary key, which is convenient to plug into the dict, which is after the as word, with SQLite dict, database name as db colon. So the thing that you're using like a dictionary is that file handle there, db. So db square brackets URL or pickled tuple, data equals that, and now you have the response object that you were sitting on top of when you originally did the crawl, or when you originally did the API request. You don't even have to make it JSON in there. You can make it the response object from whatever data fetching thing that you were using, and then you'll have the headers of the request, of the response to the request. And that's the kind of work I'm doing right now. It's nice. It's like data engineering, I guess they call it, but I do it very ad hoc. Like I do it here and there. It's not like website building. Every request is different, and every request is custom. And in the past, I used to hunger for frameworks, for generalized systems. I used to make my own. I made a couple of generalized systems or frameworks, and they were just spins on Django or Ruby on Rails. Everyone has the same ideas. If just you can, interrogate tables, imply apps, create CRUD applications, create record, update, delete around tables auto-magically, you could just reduce yourself so much coding. And so that's like all a solved problem now on the web in 1,000 different ways, and is of little to no interest to me. In fact, I'd say 9 out of 10 times just use Google Docs, Google Spreadsheets, Google Docs, whatever. You don't need a custom app. That's your custom app. Blocks and columns or whatever. The interesting stuff is just pushing data around, making requests of things, storing the results of those requests, transforming those results into some other format, usually row and column, right? So your responses to your requests most frequently come back as JSON data, JavaScript object notation, curly bracket, key value pair, nested stuff of arbitrary shape. So those arbitrary shapes are useful because you kind of simulate row and column stuff without the limitations and the weird awkwardness of being chatty with row and column stuff, because it doesn't lend itself to subsets, rectangular regions. There's a little of that. It's like Pandas has a lot of that. Pandas has a nice language for chopping out rectangular regions from row and column data grids and doing manipulations with them. However, most people don't want to do that for web communication. They want to send back and forth these, much more human readable strings with curly brackets that pair things up, and colons and commas and quotes and stuff like that. And JavaScript object notation has knocked a whole bunch of stuff off the king of the hill, namely XML, EDI, SOAP, Corba. There's a whole bunch of stuff that was electronic data interchange technology generally, ways to talk back and forth between computer systems. So as far as protocols, I mean, HTTP1 and the secure versions of it, hands down, everything talks by HTTP. There's a few other protocols that are still used out there these days, but why? FTP is insecure. SSH has some reasons when you don't need graphical stuff going on. But so I guess SSH could, but you still need data formats and enter JSON. So all these protocols are going to be able to exchange text, right? Protocols for exchanging information are normally geared towards letting you send text back and forth. In one form, that text is web pages. In another form, that text is JavaScript object notation. So you're sitting on top of text, which is formatted as JavaScript objects. And you need to store it somewhere for later retrieval. You use the URL that was used to retrieve that JSON object as the key for later retrieval. And if you're like, I don't know what that was, well, then you step through the keys. They're there. It's just a list, a sequence, an iterable. And then some mechanism is going to have retrieved that JSON, so you really have the choice of storing just the raw JSON or storing even more information about the state of affairs when you made that request by storing the whole response object. Now, response objects are implementation specific. Sometimes it's the requests response object. More often for me lately, it's the HTTPX response object. But nonetheless, it's a wrapper around a whole bunch of metadata that you normally don't interact with, but it might be useful to look at again. So when doing a transform, there's a whole lot of reasons to step through the data and to peel away layers and to do the same action on every member of that database, assuming that every member of that database was stored in the same format, which is not always the case, but let's assume that's how you're partitioning your separate tables. So, you use one of these context manager with SQLite dict as DB statements to create a file, and you just change the file name and you create a separate table, a separate database. And in this way, you can keep your data structure separate between databases and tables. So one database, one table, right? Seems like a waste, but with SQLite, why not? You're just spinning up a whole instance of the database for this one table. So it's one instance of a SQLite database, a .db file often, with one instance of a table inside of it. There might be system tables. I got to look into that sometime. It gets very meta with SQL because it becomes self-descriptive tables that store data about tables. You need to store stuff somewhere. So once in SQL, all in SQL. So there's a lot of self-referential meta tables, system tables in SQL. I don't know about SQLite. I got to go through that learning still. But there certainly is going to be user tables. So the one user table that exists is the one that you used as the file name in the context manager. In fact, it's not even going to be that. It's probably going to be called Untitled. It's going to be a table without a name, but it's always the one referred to because it's the only one in there, the default table. You could connect to that with SQLite 3. So when you import SQLite 3, you could connect to one of these SQLite dict created, things. And I did this experimentally early on to see how it was achieving key value pair database. I was like, hey, let me look at this as raw SQL string mode and see what SQLite dict is doing. And it was doing exactly what I imagined it was doing, which is utterly delightful because it means you already have alternative APIs to these key value pair things you create. If you wanted to start doing more traditional SQL, you could step in and do it. It wouldn't have as much meaning to SQLite dict. It might even break it on existing databases. But one of the typical transforms is to spin through record by record, JSON object by JSON object, and then to do a list comprehension to shape the contents of that JSON object into a flat row, and then to append that row onto a whatever, a Python table, a data frame, a pandas data frame. But by the time you come out of it, you've essentially flattened the JSON object into RDBMS mode, row and column mode. And that's the $1 million trick right there. I mean, you have data science, let's do data science and machine learning. Definitely, we want to do that. And linear regression, random tree walks, and the main workhorses that abide by the 80-20 rule. So where do I go with tech? What does Mike do? What's his shtick? Oh, Mike is Linux, Python, Vim, and Git. Sure, I advocate that as a dev platform. Not quite a stack, but it's really a dev platform. It has a solution to all your problems. Linux, Python, Vim, and Git. You should try every project first that way and see if you can't get away with foregoing most heavyweight technologies. And then there's another smattering, but they're definitely under the category of Linux software or Python packages that have similar 80-20 rule. Okay, it's time to scale. It's time to have systems talk to each other. Zero MQ is queuing without the heavyweight technology overhead that's normally inherent in that. Multiple servers set up, all kinds of crap that you generally want to avoid when you don't want to get bogged down by tech liability. I hate getting bogged down by tech liability. You got to keep it light and mobile and be honest about that being what you're doing. I'm that way with my boss all the time at work. It's like we're now able to undertake more things because we have the kinds of people with us who embrace that tech liability. They see it as what they do. Whereas I look at a system and I go, are you sure you need a database in that? I was having such an interesting conversation with one of these people who is the system's tender love and care kind of person that I don't want to be. I like my things running, from nowhere to nowhere. Headless systems, web heads they used to call them, but web heads for data. And in this conversation with this guy, he was telling me about the Google Cloud Run platform. And I'm like, okay, let me look it up, Google Cloud Run. And they make a big deal of the fact that there's no local, storage, no local device writing. It's untrue. There's no such thing as no local device writing. So if it's running as an instance in RAM, the devices you're writing to are RAM disks. And a typical such location is on Linux systems and Unix systems is the /tmp directory. It's part of the global structure of Unix and Linux. There's just always a /tmp. And it's assumed to lose its contents every time the machine loses power. It's intended to be a drive in RAM. It's like a built-in RAM disk. Truth is, it might actually be the drive in certain implementations, but it doesn't matter. Its contents are lost between power cycling of the hardware. And that's just an assumed. And a lot of things right there. There's a lot of stuff in systems that just has to write. There is almost no such thing as no writes going on. They might map it to RAM or such, but there's writes. And what was the point there? Oh yeah, the different statefulnesses, and more and more often I'm seeing stuff that's done with Docker, and there's buts, but this, but that. Persistence is an issue with Docker because what you're doing is you're mapping in a persistent location. The Docker location itself is not persistent. It will lose all state when power cycled because of their compositing system. It doesn't have to be that way. That's just one way things are under the Docker system. There's also LXD, which uses LXC containers, all the same thing really. LXC used to be the umbrella statement for all of it until they broke out LXD, D for the daemon, the service, right? The Linux service that actually runs LXCs, the containers. But they have true persistence. You can write to them. And so when you write to something like /user config files, that stays. LXD is different than Docker. And I just don't have, I don't have time for Docker. I know I'll end up using it, but I'll use it when it's not development work, right? It's just running some system, and juice, just enough, it's an app, terminology, it's an app server, you're just running something, and if there's any persistence involved, it's interoperating with some other external, maybe, cloud API driven storage system, Amazon S3 or stuff like it. That's where persistence comes from. So config, this stuff is an issue. The people who have that privilege creating that original Docker image have that ability to do that on that original Docker image. If you do it afterwards, I do believe that's the compositing system. It's like applying patches. Here are the changes that I made. So to get back to this Docker state, which was from my last time I created a config, you have to use the base Docker image and then apply these Docker composites that I have made myself. And I believe this is all under the coordination of the YAML system. And I look at all this and I go, yeah buts. My yeah buts come out. This is what I'm allergic to. There's tech liability here. And things could be just so much simpler if the APIs pushed the complexity around to the right place. Namely, in this case, Linux containers should be persistent. You should be able to write config files to the /etc directory and it just stays. Why not? The answer is there's no reason why not. So the built-in version of Docker, because Linux itself isn't going to be left out of the container bandwagon, left off. They're going to jump on the container bandwagon, and they did it with LXD. And LXD has persistent on the container images themselves. Is indistinguishable from using a Linux system. So bam, I'm there, I'm on it. That's the API I want. I want that machine to be in exactly the same state that I left it. And then those systems, those LXD'd, right now running on my NAS, my network application server at home. I'm running LXD images on my NAS server, and all my dev work is done on those now, or soon will be. I'll make those videos. Those are coming up. So to make the jump, I ought to nickname this stuff really powerfully, because I did concurrent URL requests in Python. Hot topic. I'm going to own that in not too long, because I'm going to give the one clear way to do it, the one 80-20 rule solution to really effective, high-performance URL response fetching. And I'm going to do it in a cool way, which keeps the keys that made the requests of those responses in coordination with responses, so that they can be used as keys when committing it to a database through SQLite and a key value store approach. Yeah, that says it. I feel like I want to say more, but not really. Not really. Concurrency to get data, the optional chunking it, and the committing it to local SQLite using a key value API, so you don't have to actually use SQL. You use a familiar Python dict API. And then how to transform that into other uses you may need. On that project where I fetched 25 gigabytes of data, I had to do a transform, but it thankfully involved a filter. And I was able to step through those data fetches record by record, each record having 500 sub-records. So I was stepping through record by record, but then sub-record by sub-record as well, nested, stepping through. I was building flat objects. I was building a reasonably sized flat object. So I was going from like 20 gigabytes of data to like maybe 50K of data, which could easily be stored in memory. So I used the table trick of just building a table up row by row and then turning it into a data frame at the end. So I didn't have to worry about being memory bound because the object I was building in memory was never going to get that big, even though I was stepping through, lots of data, quantity-wise, voluminous-wise, to get that 40K of data or that reasonably sized data frame. Python table first, data frame later. But there you have it. That kind of covers it. Transforms after that. Transforms often looping through SQLite and list comprehending into flat records, into flat rows. Rows are records. A row is a record which you append to a table, hoping that you don't have memory bound issues. If you do, then the transform that I would probably recommend is from SQLite to SQLite. For every step in a loop and a key value, SQLite dict, SQLite write one or more records to a import SQLite 3. Raw SQL string table is what I'm trying to say. So, you can think of it as like pouring water between two cups. Really, you're just pouring the data. The data is the water. You're pouring it from the one place, which is the shape it has because how it came in, because how you requested it, and how you could commit it to hard drive quickly or some other storage media quickly while you've been fetching it in a concurrent way. So fetch all this data. It's like a multi-headed hydra of requests going out, 20 heads at a time, each head pulling back its data, all the responses being gathered and marshaled and made available in some database writable way. Some throttling has to go on in there somewhere because, things can't be faster than the throughput of your hardware. And so all that stuff gets committed to drive, and then what next? The what next is it's easy to step through again from the drive. It's as easy to step through, to pull up and to do stuff with again as it was to capture in the first place. That's good news. Your next transform is completely custom based on why you fetched this data. What are you trying to do? So something that I know is coming up more often in my workplace because the person that we hired that is more of a engineer, data engineer type person is going to be doing our data pipelining for us. And so it's going to be a discovery process for me. I never used these systems like Airflow or Luigi. There's a whole bunch of them. He uses one called Huey, which is just apparently much more lightweight and easier. It doesn't have as many server components or whatever. Who knows? I got to research it. But I do hear a lot of talk about Erd diagrams or ERDs, So known table stuff. I hate that known table stuff. I don't want to know custom tables and have my value to an organization and as an employee come from highly stateful things, objects that are special instances that the more you know about it, the more valuable you are. Table structure. Nuanced implementations. I'm not interested. However, generic key value systems, data warehouses with some simple catalog of data that's been thrown in there that, has the idea that maybe you'll throw it in there temporarily. It's not a permanent forever record of data, because like this huge data pool, these 25 gigs that I just pulled recently, what next? I'll probably, I don't even know, burn it off to CD-ROM. Is that a thing anymore? DVD? I don't want to waste any of my hard drive space. I'll get it off my laptop by moving it to my NAS. But then the day will come where I don't want it on my NAS. So that should definitely be work. They should be able to digest that. So I have interest in the digestion of arbitrary datas that, you would describe, so that the people who have the responsibility of, controlling cost and proper care and maintenance of your data can prune it one day. Snip. We don't need that anymore. All data is intended to be pruned and trimmed and snipped, because otherwise entropy, it's not like you can store it forever. Data decays. Valuable data becomes forever more valuable by concentrating the good stuff, simplifying access to it, and making it more part of your habits and muscle memory over time than trash data, which you're never going to look at again, which should be allowed to start to flow into, nothingness, start its descent, the dissipation of the bits to dust. That should be formal, Here are the conditions under which this data loss is acceptable. Is metadata on all data. And so data warehousing, I'm looking forward to having features like that, so it can just ingest anything. Erd Diagrams be darned. So, I'm getting really close to my destination, and I should probably wrap up there. What do I got going here? I've got close to an hour. Wow, clean that up nicely. Anything more I want to say? Concurrently fetching in Python today. All my responses go in SQLite using the request as the primary keys of delight. Is that a stretch? That's a stretch. URLs make great primary keys. Barring that, tuples or named tuples are also decent primary keys. There is pickling and unpickling of those keys involved when using the SQLite dict. Pip install SQLite dict. There's also its ugly, name conventions in there. So I end up renaming the main object you use as SQL dict, all lowercase, SQLDICT. It's a beautiful API. Dictionaries should be persistent in every case where dictionaries might need to be persistent. You shouldn't have to use pickles and shelves for that, because it will be slow and error-ridden. And SQLite is a wonderful gift that has been given to us as part of the Python standard library. You should be making more use of the wonderful gifts that are in there. It's in the same category, I suppose, as regular expressions. Regular expressions, SQLite. These are gifts that keep on giving, that get embedded into software, that are often cross-language, cross-platform, cross everything, because everything can embed SQLite and everything can embed a regular expression engine, because these are parts of free and open source and have liberal licensing, as Python itself is, which is why you find it as one of the great embedded languages of Blender and FreeCAD and things like it. Liberal licensing, creative use, creative embedding of these languages, automatable host environments, I see the reemergence of many of the things that I loved about the Amiga platform. Oh, I need another hour for this video. But, you know, key among them is inter-process communication. AREX, it was called, or IPC, it was called on the Amiga, but the language that was used for it, which was written by a friend of mine, Michael Sins, the Commodore Amiga implementation of REX from the IBM world. And that was the language that was used for automating Deluxe Paint 4, Art Department 80 Pro. There's a whole bunch of really neat tricks on the Amiga computer that are being reborn now under the, you know, umbrella, under the ecosystem of Linux, Python, Vim, and Git, all of them together. So systems are becoming generic. The Amiga was great because there was the Amiga. All Amigas worked like the Amiga. You could assume all these lowest common denominator things, so all these tricks cut across all hardware, and it was always and forever useful. I love that. I fell so in love with how the Amiga tricks were just Amiga tricks. They worked that way on all Amigas. There is now a platform which is just like that, but is thousands, you know, of times more valuable. And that's Linux, Python, Vim, and Git. Not all of it, certain parts of these different things. Each one is like a lifetime. It would take a lifetime to explore and to really optimize everything and to get everything out of it that you could. But you don't need all that. You need little bits. You need enough Linux to get your Python running under different contexts, maybe under a Jupyter notebook or under a scheduler, a headless Python system, a headless Linux system with a Python scheduler running. I do that. That's one of my main tricks. And to always be able to do this, to always have these abilities, to not allow technological advances and technology drift and creeping complexity and all these things that happen in the technology world to ruin it all for you. And it does, I'll tell you. There's so many little things that happen. The move from .asp, active server page under Microsoft, you know, web technologies, to ASP.NET. ASP.NET was nothing like .asp. .asp was easy and breezy and light, and ASP.NET was this horrible thing that I wouldn't touch with a 100-foot pole. I had a mentor who kept trying to get me to do it. Hey, Michael, you'll like it, the .NET way. But, you know, the same things I hated about ASP.NET, I hate about React Redux in particular. I see all these strange, large mystery objects for statefulness and stuff that get carried around in places that it just doesn't seem natural, and it seems overly complex and weird. When, you know, HTTP isn't bad, HTML isn't bad. The approach that's taken by Flask under Python isn't bad to generic API work. And all this isn't bad. It adds up to one very good 80-20 rule. You know, it's good most of the time. Things are going to work this way forever. If you learn to do API development work on Flask and Python, especially now they're at 2.0 with concurrency, you just can't go wrong. You have a generic way of doing things. Yeah, the genericness is important. The plumbing of tech. And the plumbing of tech is Unix/Linux, but you extend it just enough to include Python, Vim, and Git, and you've got a love-worthy platform that abides by the 80-20 rule, allows you to do most of the things you need to do most of the time. Yeah, we'll wind up there. Thanks for joining me. Hope to talk to you again soon. Don't forget to subscribe.